Good morning, Gear 11s. Hey, guys. Okay, so going to get straight on with kinetics today. Whoa. You're meant to be... Oh, no. Hang on. Sorry, let's go down. Year 11, you know you're meant to keep your cameras on. Yeah. That's just downright naughty. Yeah. Watching you guys. Share screen. Otherwise, what's the point in the Google Meet? Thank you. I'm so evil. That's amazing. Suddenly realizing I'm live on YouTube and I just did that. Moving on. Okay, so awkward. I'm not evil, by the way. I am not evil. I'm only part evil. Yeah. Okay, so the very first lesson of rates, we covered the rate equation, change in product, concentration over change in time. Sorry, delta T. Oops, delta T over change in time. Made a correction. That's why it's always worthwhile reviewing previous lesson notes. Number 2, understand collision theory. So we went through the idea of what collision theory was. We talked about that particles in gases and solutions, they move randomly, they transfer energy in collisions, and that when they collide, we need the particles to have the minimum amount of energy required so they can have a successful collision, which we then termed activation energy. And then our last learning objective, which is where we got up to, was to use KCAS. Now, we didn't get to KCAS. What we then did was we talked about the factors. What things can change the rate? And I just want to make a quick note to Bene here, guys, that volume is not one of them. People think, and it's not your fault at all. Students think that, you know, when you see chemistry teachers like myself, you know, when we're blowing stuff up and we're doing, you know, flashes and bangs and color changes, you guys always like add more. Like adding more doesn't make a reaction quick. It doesn't increase the rate. All it will mean is that I will make more of the product, which may actually be a benefit. That might be a bigger explosion if I make more explosive gases, more hydrogen, for example. But it doesn't make the reaction any quicker. It doesn't increase the rate at all. So we talked about the different factors. So today's lesson, here's my today's lesson. We're doing explaining rate change. And my learning objective is to understand KCAS and what each point is doing and what it stands for. And the next one is be able to use KCAS to explain rate changes. So I'm going to be talking you through KCAS as a method. Now, this method, so I'm just going to actually put this into context. So, okay. Oh, wow, that's a fat pen. So, KCAS. Yeah. So, what this is KCAS is a method for explaining rate changes, a method for explaining rate changes, that means, a method for explaining rate changes so you don't miss points and waffle. So you guys are, I mean, I love you guys. You guys are ace. You know, you guys are amazing students. Except for you, excuse me, a cough there. And maybe Kieran. Damn it, did I say that out loud? No inner monologue. I need to work on that. So you guys love to waffle. And when you waffle, Shan, that was amazing. I love the fact that wait, what? Rue, I've not, sorry, what? No, anyway. My camera is on. You're so right. Kieran's isn't. Neither's Ruby. In all of that, the camera's on. They don't like me very much. You guys love to waffle, and the problem is when you waffle, you don't actually ever know how many points you're gonna get. Yeah, you see that these questions. Here's the question. Question number 1. Rue increases temperature of his reaction. Increases the temperature of his reaction explain the change in rate. The change in rate. So this question is 4 marks, and you guys will waffle for Malaysia. Like, it's amazing how much you guys can write. Like, I don't even know how you find the words. You just keep writing, and you might just be writing complete garbage. Like, it's brilliant. Like, I mean, I'm pretty sure I could get Shan Lee to write a 6,000 word essay on this question. I'm pretty sure I could, and she'd probably be able to do it without even breaking a sweat. Like, I mean, you guys are amazing at waffling. Yeah, I did actually think about putting in some of you guys for the, you know, Waffle of the Year competition. Yeah, I'm pretty sure though that was to do with cooking and not writing. Yeah. Anyway, I bet Shan Lee could do a Waffle of the Year competition though as well. Yeah, Shan Lee's amazing at baking, by the way. She's amazing. You should try her lemon drizzle cake. Oh my god, it's just to die for. It's amazing. Anyway, moving on. So the way that when I first started teaching, I had no method for this. I would talk to the students about the kind of things they'd be wanting to say, but I realized really quickly a couple of years in that I really needed to structure this for students so they understood what they were doing and what each mark is meaning. So I created KCAS. So KCAS is just a method for being able to hit all the points and to be able to do it in a concise, speedy fashion. This goes from Shan Lee's 6,000 word essay, which takes her about 14 minutes. I know, right? She is that good. Like, seriously, she could do a 6,000 word essay in 14 minutes. She's amazing. Yeah, it goes from being a 6,000 words for being a concise, simple process that you can run in under 60 seconds. So 4 marks in 60 seconds. That's pretty good, but it needs practice. So what does each stage do and what's its function? So the K in KCAS stands for knowledge. Now this knowledge is knowledge of particle theory. So knowledge of particle theory. So we're explaining what the first step is to say what Rue has done to the particles. That is stage number 1. Next one, the C stands for collision frequency. Now, some people like to add in the F into KCAS. Yeah, I don't like it. KIFAS. Yeah, I don't like it. I don't like it. Don't like it at all. So just collision frequency. This is why it does need practice. So this is how frequently are the particles colliding. Yeah. The next one is particles with, now this is a tricky one, number of particles, parts with the activation energy. Activation energy. Energy. Symbol EA. Like, it's always nice to do that. So this is the number of particles with the activation. I know that people then go, well, hang on a minute, KCAS doesn't work then, does it? Because you just go knowledge, collisions, activation energy, and the next one is the number of successful collisions. I know that it requires a translation, but KCAS is easy to remember, and it usually, you guys are pretty good at being, like, your brains are pretty good at being able to fill in the gaps. Like, you remember these key words, and all of a sudden, boom, the rest of it's there. It's really cool, that. So this is the number of successful collisions. Yeah. Now, students think that the collision frequency is the same as the successful collisions. They are not. They are independent marks. This is why KCAS is so useful, because most students who waffle this answer will not score 4. Yeah, they won't. The last question is explain the rate change. Yeah, so then you go, the last one, if you want to do KCAS, you have to be a pirate when you say it. Yeah, rate change. Yeah, so that's going to be an increase or decrease. So some people like KCAS. I don't. I just like KCAS. I just remember to always mention the rate at the end of it. Rate increase, rate decrease. I always do that at the end. But I do understand if some people like to add KCAS to the end of it. Yeah, if you're gonna do that, please make sure you say it in a pirate voice. KCAS. Yeah, that's what needs to be done. Yeah. Anyway, moving on. So what we now need to do is we now need to use KCAS. Now that we understand what each point is doing, we now need to use this to answer Rue's question. So Rue's increased the temperature. let's apply this. Okay, going to just switch to red here as an answer. Seems reasonable. So what I'm going to do is I'm going to put onto the classroom. So, okay, knowledge of particle theory. Rho increased the temperature. Okay, so what's going to have happened to the particles if I increase the temperature? Now, you guys can, what I'd like you to do is, I know the problem is there's a delay. Oh, it's going to be tricky, this. I feel like what I'm going to do is I'm going to do I'm going to do a couple of examples and then you guys can have a go at the rest. So knowledge. So Rho increased the temperature. Knowledge. Particles gain kinetic energy. What is wrong with me today? Look at that. I can't even spell energy. Energy. I love a bit of energy. Oh, come on. Come on. My laptop is proper slow to a halt. Come on, Mr. Duncan. It's energy. There we go. Oh, my goodness. There we go. Particles gain kinetic energy, so move around faster. So move around more. So move around more. I like it. So the particles gain kinetic energy. Can I just point out, by the way, that pretty much gets you the mark, that does. Yeah, it's nice to mention this because it's nice for me to have this idea and I can actually show you guys this in an animation. Yeah. So the animation, which you guys know that I tend to use, is this one. It's called AtomScope. Any teachers out there or students, you can download AtomScope for free on a couple of websites, and it's a really, really useful tool. Any chemistry teachers who don't use this, I'd recommend it heartily. It's one of my most used animations just because it ticks a whole lot of boxes. You can actually download a second version of it as well. It's not loading for some reason. It's because my laptop is really struggling here. I'll try opening it again. I'll wait for that. What I'll do is I'll go back to my lesson and wait for that to appear. Oh, yeah, I don't want to do that. It's really struggling. Okay, moving on. So, guys, if the particles are moving around more and they're moving around with more kinetic energy, yeah, move at a higher rate. Oh, no, you can't, Isabel, you can't use the word rate there. That's really important. Yeah, you can't use the word rate. They're just moving around more. They're moving around faster. You can use the word faster there if you like. Yeah, because that is actually to do with speed. They're covering a greater distance in the same amount of time. That's okay to use in this situation. But they're moving around more. Don't say the word rate yet. Yeah? Okay, so if the particles move around more, what's going to happen to the frequency of their collisions? How often are they going to collide? Is it going to be more? Is it going to be less? Or is it going to be the same? Collision frequency will increase. Will increase. They're going to collide more. Yep, now that is a separate, thanks very much, Ben. Absolutely. The collision frequency is going to increase. Now you need to actually say that. You can actually put that in other words. You can say the particles will collide more frequently, or you can even say the particles will collide more often. That is totally allowed. Absolutely fine. Yep, the next one is number of particles, number of P's with activation energy. Oh, if I increase the temperature, I know that more particles are going to have the activation energy. So more particles will have the minimum. I'm going to put the activation energy, but I like to translate activation energy, the minimum amount of energy required for a successful collision. More particles will have the activation energy. Therefore, there will be. Therefore, you right? Yeah. Therefore, there will be more successful collisions. More successful collisions. Rate increase. Rate increase. We're done. So it's quite nice. KCAS is super handy because all of a sudden, instead of waffling, you're just hitting these 4 marks, which most students don't get anyway. And You're doing it in an ordered fashion where the marker goes winner, 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 chicken dinner, you get the grades. Yes, Ruby, you do. More particles have activation energy. If you said, Ruby, you can actually say more particles have than the minimum amount of energy required for a successful collision. If you want to do that, you can, but it's an awful lot more words. But you can if you like. Okay, let's have a look at the next one. Because we've got 5 rate changes. 5 rate changes to explain. We've now done temperature. Come on, laptop. Oh, the problem is I've now opened up this thing. I've now got 2 of them open. Get rid of that. So it's just nice to show you guys. Come on. There we go. So if I lower the temperature, the particles lose kinetic energy. They move around more slowly. If I increase the temperature, the particles gain kinetic energy and will move around more quickly. Yeah, move around faster. Therefore, they will collide more often. More particles will have that minimum amount of, more particles will have the activation energy. There will be more successful collisions. It's cool that. It works really well. Right. We've got a couple more rate changes to explain. So let's run through them. Whatever you're eating sounds delicious. Ben, that's funny. I was eating an egg. Oh, come on, laptop. Really, really, really struggling. Holy moly. Come on. Come on. I've lost my notebook. I won't know how to open it. Oh, it's closed it. It's kicked off. Laptop's just going, no. Mr. Dankin, no. There we go. I'm back. Winner. Okay. So we've now done temperature. What we now need to do, oh, come on. It's a really bad idea starting up that program. Really bad idea. Laptop is seriously struggling. Oh, I think it's because I've now got 2 of them open. 3 of them open. Oh my goodness. I'm so sorry about this, guys. That'll teach me to fiddle. There we go. Okay. Is it going to work now? Is it going to work? Is it going to work? Still thinking about it. Oh, I've opened another one. Of course I have, because I'm... Right, let's try this now. Still not working. Still not even letting me write. Still trying to open another one. And another one. My laptop, there we go. Just going to continue now. Right, I need to set up... Oh, this thing's killing me. I'm sorry, guys. I'm so sorry. It's still another one. I don't know quite why it's doing this. Just going to close everything down. Go away. Go away. It's just opening it up randomly. Oh dear. My poor little laptop. Poor little laptop. Poor little lappy. I haven't got a huge amount of time, have I? Let's try this again. Okay, question number 2. Question number 2. Moses, let's just, sorry, I'm not actually asking you a question, Moses. I'm going to use you in a question. So I just want to go back to so concentration is the next one. Let's go for conc, pressure, surface, catalyst. Okay, conc. So Moses decreases the concentration of HCl in his reaction. Explain rate change. Okay. Kick-ass. Go full pirate. I like it. Okay. Answer. Knowledge. It's great how this thing's knowledge just doesn't work as fast as I do. That's how awesome I am. That's how quick I am. So knowledge. Okay. So what have we done? So what we've done is this. Oh, I don't want to open that animation up again because it'll freak my laptop out. Here's what Moses has done. He's done this. He had acid of this concentration. Yeah, 6 moles per dm cubed. He's now done this. He's now decreased the concentration. He now only has 2 moles per dm cubed. The kick-ass is there are fewer particles, yeah, fewer knowledge, fewer particles per unit space. Fewer particles per unit space. There's your knowledge. Okay, collisions. Come on, little man, come on. Come on. I don't know why it's funny, it's so hard. Okay, KCAS, collisions. Right, collision frequency will therefore decrease. Will therefore decrease. If there are fewer particles in the system, then they're going to collide less frequency. If I put more particles into the system, they're going to collide more often. It's a bit like, can you imagine if you took a football team and reduced it to 2 players? Yeah, the chances of them actually touching the ball become rather small because they're just going to get passed around between the other players on the other team. Yeah, so it's to do with the amount of collisions they're going to have. The collision frequency will therefore decrease. Right, activation energy, number of particles width. Now, has Moses changed the energy of these particles? The answer is no. This step does not need to be done for concentration because we haven't actually changed the proportion of molecules with the activation energy. The ratio is still the same. So you skip it. Because the only time you ever mention activation, the particles with the activation energy, is either temperature or catalyst. The rest of them is to do with collisions. Right, so what happens to the number of successful collisions? So we've now said fewer particles per unit space, collision frequency will therefore decrease, therefore fewer successful collisions, rate decrease. Fewer successful collisions, rate decrease. There we go. Now that one's only 3 marks rather than 4 marks. The temperature one is slightly more because you've got to comment on the number of particles with the activation energy. Cool, so there's concentration done. So we had temperature, concentration, pressure, I believe the next one is. Let's just check. Pressure and gases. Now there's a reason why I put these two next to each other. The reason being is they have the same explanation. Because pressure in gases is the same as concentration in solutions. What I need to do is just start using those pens over there, but then there we go. Okay, question number 3. Question 3. Vic increases the pressure of oxygen gas, brackets O2, oxygen gas in her reaction. Explain rate change. Okay, so what does that look like? Knowledge, collision frequency, number of particles with activation energy, successful collisions, KCAS, pirate. Right. So knowledge, what does it look like? What does it look like? So Vic had a container with oxygen gas in it, and she has increased the pressure. There's 2 ways that she could have done this. Number 1, add more gas. That'll raise the pressure. Or number 2, reduce the size of the box. Do you realize it's the same as concentration? There are more particles per unit space. If she added more gas, well, she's gone for 3 particles in the same space that there was 2 previously. If she decreased the box size, then she had 2 moles of gas in a smaller space. The knowledge is the same. More particles per unit space. More particles per unit space. Next one, collision frequency. What's that going to do to the collision frequency? Oh, they're going to collide more often. Therefore, collision frequency collision frequency will increase. Next. Activation energy is only for temperature and a catalyst, so I skip it. Therefore, if they're colliding more often, therefore, more successful collisions. They're colliding more often, more successful collisions. More successful collisions. Rate increase. We're done. Isn't that neat? So we've done temperature, we've done concentration, we've done pressure. We love pressure and concentration because they're exactly the same in their explanation. KCAS is identical. Now we need to go to surface area. Now that one is slightly different. Let's go for surface area. There we go. Starting to figure out what my black pens were up there for. So question number 4. Nick increases. Oh, no, I'm going to put you into a much more common GCSE setting. Nick grinds his limestone brackets calcium carbonate, his limestone chips into a powder. Explain the change in rate. Explain the change in rate. KCAS. You guys love my pirate sound, don't you? Give me a thumbs up if you like my pirate sound. I've lost my marbles. It's been a long day. I don't think we've started either yet. Answer. Oh, no. No, too skinny. Too skinny. Yeah, Con gave me a thumbs up. Everyone else ignored me. You guys, come on. Whatever. Used to like you guys. Not anymore. Answer. Right. KCAS. Knowledge. Right. So what's he done? So if you grind chips into powder, this is surface area. So knowledge. Nick has increased surface area. Now, the problem is we haven't mentioned the particles yet, and we need to. So if he's increased the surface area, let's look at what that looks like. That looks like, oh, darn it. Okay, it looks like this. He started off with a marble chip. He then cut it into a powder, which is really tiny pieces. Now, what that means is it's got the same mass of it, but now much larger surface area. And by the way, I suddenly realized I needed to make that. So what I need to do is here's his original chip. Yeah, and there's his powder. Yeah, so what's happening is he's increasing the number of particles that are available for collision. Yeah, because the inside the box, all of these particles inside can't react because they're not available. They're protected by the outside, whereas now they're not. So Nick has increased surface area, more particles are now available for collision. And more particles are now available for collision. Right. So what's that going to do to the collision frequency? Everyone knows the answer. I don't need to run these anymore. You guys are getting this now. You're like, yeah, okay, I kind of get what he's doing. Yeah. Collision frequency, therefore, increases. Collision frequency, therefore, increases. Have I changed the temperature? No. So I ignore activation energy. Collision frequency, therefore, increases. I skip A because that's only for temperature and catalyst. Oh, more successful collisions. Therefore, more successful collisions. People skip the successful collisions one, and it is not the same as the collision frequency. It's not the same. More successful collisions. Rate increase. Done. Cool. I think we've only got one to go now. Catalyst. We do. Just catalyst to go now. Okay. Catalysts. Question 5. Done, Nick. done Rue, done Vic. Who else did I do? Can't remember who else I do. Who else did I do? Nick, Vic, Moses. I didn't use anyone for the first one, did I? Oh, yeah. Rue, Moses, Vic, and Nick. Rhymes. Let's go for Ruby. Ruby. So Ruby adds a catalyst. Adds a catalyst to her reaction. Explain. Rate change. Cool. So, particles. Oh, KCAS. KCAS. Okay. So, knowledge. So the problem with the catalyst one is it requires a bit more detail, because in reality, what you haven't actually done is changed the particles in any way, shape, or form. You haven't actually altered them. All you've done is you've added in a separate reagent here, which is going to act as a catalyst. So we need to explain what the catalyst is doing. So the knowledge here is a catalyst. A catalyst provides an alternative reaction pathway with, underline with, oh my Lord, everyone forgets it. If you don't say that, you just lose this. Yeah, with a lower activation energy. Right. What has that now done to the particles? We've explained what, I'm just going to move KCAS R down. KCAS. There we go. So what does that now do to the particles? It's adding in the A. So what's going to happen to the collision frequency? No change. No change to the collision frequency. They're not going to collide more often. They're not moving around anymore. Yeah? But what it does do, more particles now have the activation energy. More particles now have the activation energy. Therefore, more successful collisions. Rate increase. Therefore, rate increase. That brings us to the end of KCAS. It's quite nice. I just want to do a little bit. I know that my lesson ends, I think, at 10. So it's not that. I just want to, I don't really need to go any further than that. So now that we've run all the KCASs for all 5, at this point, I'm going to go back to learning objectives. It's always nice just to check that we've done everything that I wanted to achieve this lesson. Okay, zoomed right out. Okay, so KCAS and know what each point is doing. We did that. We talked through it. We went, wow, I really have gone ridiculously big now at this point. I need to shrink all my writing down. Use KCAS to explain rates. We've done my 2 learning objectives for today. Now, guys, what I'm going to do is I'm going to post onto, look at that, I've just got bigger and 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 bigger every time. It's ridiculous. I don't know why I do that, but I do. Yeah, I'll just shrink it all down. I'm going to end the lesson there today, guys, and I'm going to post on the classroom. Go. Yellow. Is it going to work? Wait, there we go. I'm back. Oh, it's a bit, yeah, sticky. Anyway, guys, I'm going to leave you be at this stage. I'm going to post on the classroom some questions for you to practice KCAS. You can then just submit them on the classroom when they're done, and then I'll go through them next lesson. And at this point, I'm going to do a few more lessons on catalysts just to show you a bit more information about that, because I think there's value in it. But we're making good progress, and I'll see you guys soon. Have an amazing weekend, everybody. It's nice to see you.